Good afternoon, everybody. Welcome to a sunny, wonderful afternoon of Chem 1105 with your host, me, Dr. White. Hi, everybody, and thank you for turning on your webcam so I can see real people out there. Thank you. All right. First of all, I'd like to make two things, one clarify and one make an announcement. You should see on your screen right now, and I'm in student view. This is announcements in Blackboard, and you also got an email because of some personal stuff that came up this week unexpectedly, and it shouldn't happen the rest of the semester, and I apologize. But for tomorrow's Zoom meeting, instead of from 3 to 5, it will be from 7 p.m. to 9 p.m. Again, only tomorrow, Thursday, the Zoom meeting will be from 7 to 9 p.m. Now, you use the same Zoom login that you used for today. It's just a different time. Now, if you can't make the meeting tomorrow at 7, good news. Just like all my Zoom meetings, I'll be recording it and posting a video of that on my YouTube channel. In fact, if we look at my YouTube channel, you'll see I have all the lectures Monday and Tuesday this week. Hopefully today's Wednesday. Oh, look, my computer says, yep, it's Wednesday. Wouldn't want to lose track. Who's that wonderful guy on the screen all over? Me. But anyways, this Thursday, we will have our meeting tomorrow from 7 to 9 p.m. Again, you use the same Zoom login. Now, the other thing I'd like to clarify is if we go to assignments, and I apologize, I had the wrong contract up. You'll now see under the safety contract, COD DL lab safety contract. And notice I had said you have to complete these contracts, both. And turns out I had an older one from last semester where they had two separate ones, and they now have it all in the same file. You need, and let me make sure, you need to fill out the first page where you put your name in. Also read this, please. And then the second page, again, read this. Everything in here I went over yesterday, except about the broken glass. That I didn't. Use a dustpan and broom, never your hand. You'll cut yourself. And here they say you should have a fire extinguisher. I don't know about you, but I have a fire extinguisher in my kitchen. And you'll need to sign this, date it. The course is Chem 1105. The section is Net 04, and I'm Dr. White. And I need this as soon as possible. If you get this uploaded by tomorrow, the end of the day, I will give you three bonus points. So it's in your own interest to do this ASAP. Again, this is located in safety contract of assignments where it says COD/DL lab safety contract. Now, if you've already uploaded the old one, go ahead, download this, fill it up, write in your name and everywhere, sign it where you're supposed to, and upload it a second time, please. All right, I think I'm up to date on all that. So let's get to work. Now, yesterday I finished chapter 1. And let me check something while I'm talking. If you see on your screen, you'll see Chem 1105 Practice Problems, Chapter 1. And next Monday, I'll go through this. You should do this before I do. So I highly recommend, if you want to get a good grade, you have to do the practice problems. And next Monday, I'll go through Chapter 1, Practice Problems. In case you're wondering, where do I find these practice problems? You go to Blackboard, where it says Course Information, click on that, and you'll see 3 folders. And in the recommended problem set folder, you'll find the recommended problem sets. I have them both as a Word file and a PDF. And I also have in another folder the answers to those problem sets. But don't look at the answers until you try them. If you have trouble doing them, Monday I'll be going through it, entertaining questions. You can always come to my office hours, or you can always email me. Again, Monday, I will go through the Chapter 1 practice problems because we finished the chapter. But now it's time to move on. Now, the book threw this at the end in Appendix A2 and A4. It actually should be in a chapter like Chapter 2, but they'd have something else. So I'm going to do it out of order because this makes more sense. And Appendix 2A and or A2 and A4 deal with what's called measurements and problem sets. Now, measurements, and I'll never ask you what's a measurement, is determining dimensions, capacity, quantity, or extent of something. How long is something? How many minutes has gone by? And how much does something weigh? Those are all measurements. Now, chemists measure many things, and that includes mass, which really means weight, volume, how much there is of like a liquid, length, time, temperature. We'll learn later on in the semester about things like pressure, concentration, and other physical and chemical properties. You don't know, and we won't go through it in this class, but the octane number on the gasoline pump is a measured number. How well something combusts is a measured number. There are tests for that, combustion. In fact, years ago, for one of my patents, I had to measure the combustion of my new product in urethane foams. And I went to the underwriter's lab here, and I can't think of what suburb it is, one of the northwest suburbs underwriter's lab is. And we did flame tests in these huge 20-foot long flame tunnels to measure that. I'll teach you later on about pH and many other things. We won't get to it in this class, but when I worked in industry for a number of products, we measured color. An example, water has a 1 scale called APHA for cosmetics, and very pure water has an APHA 0 or 100. And the more slightly yellow it is, the higher the APH number. And there are other color measurements like Lovibond and so on, which we won't go through. Now, when we talk about measurements, we use numbers. And everybody take a deep breath, let it out. Take a deep breath. Are you nice and relaxed? Let it out. We'll be doing some math. I will show you how to do any math in this class. I will teach you how to do it. And the way I teach it, students do well. So relax when I say math. Ooh, or anything like that, or even algebra. Ooh, don't do that. All right, let's go through. There's something called scientific notation. And this is a system which allows scientists, like chemists, we're scientists, to easily represent a decimal number in a very short way. And that decimal number can be very big or very little. And this is called scientific notation. And it's expressed as a product of a number between 1 and 10 times 10 raised to the power of 10. Hold on one second. I have to get something. My, my stylus pen was still on the charger. All right. So the question is, what is scientific notation? It's a number between never less than 1, never 10 or greater, times 10 to a power n. Now, let's look at something. This is 10. If I multiply 10 times 10, well, you know that's 100. Well, in powers of 10, that's 10 squared. 10 times 10. 10 times 10 times 10 is 1,000. But in a power of 10, notice we have 1, 2, 3 tens. That's 10 to the third. And you can go on higher numbers, and we will in this class. Now, what is scientific notation? Scientific notation converts a decimal number to scientific notation, a smaller, quicker way of writing a number. And always the decimal point in a decimal number is moved to the position behind, otherwise known as to the right, of the first non-zero number. This should be number meaning non-zero. And then the exponent 10 to the n, that n for the exponential term is equal to the number of places the decimal point has moved. If the exponent is positive, if the number is greater than 10. The exponent is negative if the number is less than 1. I never use, but some people do, I don't. The exponent is 0, 10 to the 0 equals the number 1. And I don't use that. I've never seen anybody write scientific notation between the number 1 and 10 alone. You just write the number. So let's take a look at how we do this, because this is a skill you should know. In fact, all right, let's take a number like this. 1,230. How do you write it in scientific notation? Well, if there was a decimal point here, we're going to move it to the right of the first non-zero number. 1, 2, 3. So we've moved it 1, 2, 3 times. Now, when the number is greater than 10, and there's no explicit number, you drop the zeros at the end. So this would be 1.23. Now, it's times 10 to the n. Remember, x times 10 to the n is a scientific notation. And n, when the number is greater than or greater than 10, n is positive. Now, if we look over here, how many times do we move it? 1, 2, 3. So that would be 1.23 times 10 to the third. And that's how we do it. Let me do another one. Remember, when there's a 0 at the end with no decimal, you drop it. Now, how would you write this in scientific notation? If I said 3 points or 2 points each, write the following numbers in scientific notation. Well, if there were a decimal point, it would be here. And you move the decimal point to the right of the first non-zero number. So how many times do we have to move it? 1, 2, 3, 4, 5. All zeros at the end when there's no decimal, and there wasn't, because I wrote this down to show where it might have been, are dropped. So this would be 1.2 times, how many times do we move it? 1, 2, 3, 4, 5. Numbers greater than 10. So that would be 1.2 times 10 to the fifth. You know something? I'm going to share the fun. Why don't you write this in scientific notation? 34,500. Your turn. Remember, you move the decimal, if there was one, to the right of the first non-zero number. Zeros at the end without a decimal, and like this one, are dropped, and it's greater than 10, so n is positive. Oops. I see somebody's already done it. Let's wait. One thing I have now, which I can do, is launch a poll. And if you're done, click on yes, don't do choice 2. And that way I know you're done. And everybody's done, so it's my turn. How do we write this number in scientific notation? There are decimal point here. You go 1, 2, 3, 4. And the zeros at the end, there was no decimal point originally, are dropped. So this would be 3.45. Now, what's n? How many times we moved it? Oh, that was fun. We got to do another one. Remember, this is how I write the 7. And here's one more for you to do. Write the following, what is that, 7,080,000? Write that in scientific notation. It's your turn to have some more fun. If I say fun enough times, you might believe me. And when you're done, vote yes. All right, everybody's done. So it's my turn. How do we write this in scientific notation? If there was a decimal point, you move it to the right of the first non-zero number. if the decimal point was here, 1, 2, 3, 4, 5, 6. So we moved it 6 times. 7.08, any zeros at the end, these, when there was no decimal, which there was, and I put that down, you drop. As 10 to the n, what's n? How many times we moved it? Now, on a test, you don't have to write these down if I were to ask this on a test, but the more you let the paper do the thinking when you're first starting out, the better it is for you. All right, let's look at another number. These numbers were greater than 10. What about this number? How would I write that? Well, you do the same thing. Now we do have a decimal point, and you move it to the right of the first non-zero number. 1, 2, 3. And here, since we have a decimal point, lead zeros you drop, but zeros at the end you would keep, but there aren't any. So this would be 3.5. We moved it 1, 2, 3. Now, when the number is less than 1, this means less than, n is negative. So this number is definitely less than 1. We moved it 3 times, so that would be -3. So again, take the decimal, move it to the right of the first non-zero number. Lead zeros are dropped. Trailing zeros like this number when there's a decimal point are not. Let's take a look at that. Let's look at this number. And the question is, write the following in scientific notation. Well, there's a decimal. So we're going to move it to the right of the first non-zero number. 1, 2, 3, 4, 5. So we moved it 5 times. And therefore, I drop all these zeros, 4.3. But now this 0 is after this decimal point that was there. And I keep that. Times 10. Now this number is less than 1. So n is negative minus 5. And that's how you do scientific notation. But oh no, I've got to share the fun. And here's one for you to write in scientific notation. Your turn. And while you're doing that, let me check something. That's not what I wanted. All right, it works. You're going to find out that Dr. White's a Zoom pro because a little while we're going to be doing work with 2 separate webcams. All right, let's do this. How do we do? Oh, I forgot to send out a poll. Hold on. Remember, vote yes if you're done. Everybody's done. So how do we write this number in scientific notation? Here's the decimal. we move it to the right of the first non-zero number, 1, 2. This number is less than 0, so n is negative. It would be 7.112 times 10 to the 1. We moved it 2 times. It's negative because this is less than 0, 2. Let's do one more. And here's one more for you to do. Write the following in scientific notation. Let's see, one person, I better launch the poll. Everybody's done, so it's my turn. Here's the decimal point. We'll move it to the right of the first non-zero number. 1, 2, 3, 4, 5. Zeros and the lead zeros are dropped, 3.1. Now, this 0 is after the decimal at the end. We'll keep times 10. Notice it was 5, but this number is less than 1. Therefore, n is negative. And therefore, it'd be negative 5. 3.10 times 10 to the negative 5. And that's how you do scientific notation. Now, a while ago, like a couple of years ago, I used to also have students hear scientific notation and now write it in decimal form. So I thought about, we don't really do that. So I don't teach that anymore because it's not really necessary. Now, we just did our practice. Notice I have going back and forth. We're not going to go from scientific back to decimal. Now, when you multiply and divide in the old days, you don't need to know this because you have a calculator. I hope you have one soon. And if you multiply 10 to the A times 10 to the B, that's equal to 10 to the A plus B. If you divide 10 to the C by 10 to the D, that's 10 to the C minus D. Now, back when I was in high school and college and grad school, calculators hadn't been invented until I think it was my 4th year in grad school. HP came out with their first calculator, and it was real expensive. It was $500 then, which would be, I don't know how many $1,000 today for a calculator. It was good, but I'm not going to buy one. I had a slide rule. But right now, what I like to do is something very important. That's teaching you how to use a calculator, a scientific calculator. And what we're going to try and do, and it'll be a little bumpy at times because I'm holding the camera by my hand, is here I have my calculator. Now, what I'm going to do is turn it on and clear it. Now, at the top here, if I push blue key, and then this keyword says SCI on top, you'll now see 3 things: flow, SCI, and engineering. You can see I'm never going to be a hand model on TV. And you'll use these cursors to make sure the SCI is underlined. You can move it like to this or to this, but you'll have it under SCI. Again, second key then the key that says SCI above it, and then you'll hit enter. And now we're in scientific notation, which you'll need how to do for my class. Now, let's take a look at the following. What if we were to multiply 2 times 10 to the 5th times 3 times 10 to the 6th? How do you do this on a calculator? Well, let's find out. All right, now, the first number 2, I'll put in, and you see that. Now, watch closely. To do the scientific notation, hit the second key on mine, it's blue key, and then right here, you'll see above x to the -1, double E. That puts you in scientific notation. So I did second key, double E. And you'll see an E on there. And that means 10 to the power. And I think I had 5, so I'll put 5. Now I want to multiply that times. So I'll hit the times button. And you see the little star there. 6 times 10 to the 6th, I think I had. So how do we get 10 to the 6th? Blue key, then right here, the double E on the top, and notice the E comes through, and we want 6. And now to get the answer, you'll hit enter, and you'll see it's 1.2, then very little times 10, and then here to the 15th. So that's how you do it. Let me do another one. Let's clear it. And I'm just writing down a piece of paper so I remember it. Let's do, oops, wrong stylus. So 4.5 times 10 to the 3rd times 6.8 times 10 to the 5th. How do you do that on the calculator? Well, first of all, I'm going to clear it. And the first number, I want 4.5. And now I want to go 10 to the 3rd. Again, second key, and mine is blue key. And then right here above x to the -1, you'll see the double E. In most calculators, this is the way it's done. And you'll see I did something wrong. Hold on. Let's do blue key, double E, and see the letter E. That means 10 to the power. And I want 3. So I'll click on 3. And that's 4.5. E means 10 times 10 to the, now 3. I'm going to multiply it by 6.8. And now I want 10 to the 5th. Second key, double E, that's the above the x to the minus 1, the same key. But since we're in the second key, it's the letters above it. And notice again, you see the letter E, and we want 5, 10 to the 5th. And now hit enter. And it gives me 3.06 I can hold it straight, hold on, times 10 to the 9th. And that's how you do it for this. But now I have to show you something that's a little tricky, and I forgot to write the other answer, but this was 3.06 times 10 to the 9th. Now let's look at the following. Oh, let's make that a 6. I've already used 5. Now this is different. What's different? N is negative. And this is something students initially have trouble with, so please pay attention. All right, first of all, hopefully you're not getting dizzy. Come on, focus. I'm gonna clear. And now I want 2.1. That's better. And we want 10 to the minus 2. Come on, focus. Why are you being difficult right now? All right, there we go. We'll do blue, double E, and next, notice I have the letter E. Now, to do a negative, this is very important. You do not use the negative over here. That's for subtraction. You don't use this. What you do use is the negative on the keyboard right here in the bracket. That's to make the exponent negative. So I'll hit negative. You'll see up here I have a negative sign. Now it's, and I want 2. And now I have 2.1 times 10 to the minus 2. Now I'm going to want to multiply it. And my second number will be 3.45. And now we want 10 to the minus 6. So it's second key, double E. Again, listen carefully. You do not use this one. This is for negative. Subtraction, not negative. To get a negative exponent, you use this one on the keypad. And I'll hit that, and you'll see up here, I have right here, E minus, and now I want 6, and now 4.5, 3.45 times 10 to the minus 6. I'll hit equal. Now, look at the number I have. I have 7.245 times 10 to the minus 8. 0.8, you can drop the 0. But it's important that negative is important where it says 10, very little x10, then above that minus 0.8. And that's how you do it. And the answer here, 7.245 times 10 to the minus 8. You put 0.8, you don't have to put the 0 there. Now, I've done multiplication. Let's do a division. And let's do 4.2 times 10 to the 12 divided by 2.3 times 10 squared. I'll clear it. And now the first number is 4.2. And now I want times 10 to the 12, second key, double E, and then I want 12 as a positive number. Now to divide, we use this key right here. This means divide. You'll see there's now a slash there. And the number on the bottom we want to divide by is 2.3 and times 10 squared. So second key, double E, 2. And now I'll hit enter. Notice I have 2.3 E2. That's 2.3 times 10 squared, 10 to the 2. And now I get this long number, 1.826086957 times 10 to the 10th. Now I'm going to shorten it down to 1.82 times 10 to the 10th, and I'll teach you why I did that in a little while. And I'll put one more times 10 to the 6th times 10 to the 10th. Let's do one more. And that would be 3.8 times 10 to the minus 12 divided by 8.5 times 10 to the minus third. And let me write that down or I'll forget it. We're in a classroom, I could look at the board, but when I'm on Zoom, I can't when I switch back and forth. All right, let's do this. Clear it. The first number is 3.8 times 10, so that's blue key, double E. Notice the E is right up there. And now I want minus 12. Remember, for minus exponents, we use the minus the bracket on the keyboard, not this one. This is for subtraction. This is for minus. So we want minus, and you'll see there's a minus up there, 12. Now we want to divide, so I use this key by 8.5 times 10. So I'm going to do blue key, double E, and then we want minus and use this one, not the one over here, this one, and that would be a 3. And notice I have 8.5 E means 10 to minus 3. I'll hit enter, and the number I get, I'm going to round this off, and I'll teach you later today rounding off, 4.470. But notice right here, times 10, and then right here, and they have it right above there, and students forget that, minus 10. So it'd be 4.470 times 10 to the minus 10. And that's how you do it. And I successfully used 2 webcams. By the way, if you're ever wondering, what do I see when I'm looking at you? Here's the screen above my desk. Can you guess what is my favorite color? And as I said, I have 2 big speakers, so if you ever talk, I can hear you well. I have a clock up here. I've got another clock, which is really a 100-year calendar. And here's some of my hobby stuff right there, including my flashlights and my messy work desk, which I have to clean this next day or two. It needs a good cleaning. All right, let's get back to the other camera. Is that cool or not, that I can use 2 cameras at one time? Don't answer that. All right, but seriously, you need to know what I just went through in the video, or I'm live right now. If you're watching this video later on, you can go back and watch it a couple of times. Now, listen carefully. I highly recommend you buy this TI-30 XII. It's in my syllabus, solar. This is the easiest one to use. If you have a different calculator and you can't get it to work right, the problems I just showed you, come to my office hour or email me and we'll set up a special time. There is yet to be a calculator. I have not helped a student learn how to do it. You know, some of the more expensive graphing ones, which you don't need for my class. But if you've already bought it, you don't have to go out and buy another one, and I can help you. Any questions? Oh my goodness, time flies when we're having fun with scientific notation and calculators. And it's very important that you know how to do scientific notation, multiplication, division. Now, let's move on right before the break. Now, let's assume you have a ruler and you measure a distance. The number you get when you measure a quantity such as length, I just said, is a measured number. And whenever you measure a number, there's always uncertainty in the measurement. And in any measurement, the last digit is always uncertain, but it's the only uncertain one. Let's see if I can find something on the internet. You see on your screen right now, let me make sure that's what you're seeing. And the answer is yes. You see that on the right, that ruler with a pencil. And you can see the marks. 1 centimeter, 1.5 to 2.53. And notice the length of that pencil is not right at 4, is not right at 4.5. Now I could say it's halfway between 4 and 4.5. I could call that, say, 4.2 or 4.3. So I know with certainty that pencil is at least 4 centimeters long, but the last one I've guessed at, and it's uncertain. Is that exactly right? No. Well, it turns out measurements and uncertainty play an important role in our life. And with that, if I look at the, oh no, the time, it's time for a 5-minute break. come back in 5 minutes and we'll continue with Chem 1105. I'll see you in 5. I'm going to get up and stretch. Let's get going. Welcome back. All right, we're talking about measurements. Whenever you measure something, there's certainty and uncertainty in your measurement. And as I showed you with the ruler here and the pencil, I know for certain it's at least 4 centimeters long. And then how actually it's between 4 and 4.5. I could call that 4.3. I could also call that 4.25. So the measurement is never exact when you measure something. There's always uncertainty in a measurement. And here's another example with the graduated cylinder I'll teach you about. How do you measure that? Well, it's 21 point, this line is 20, this is 21, this is 22, and it's halfway between that. So I could say that's 21.5, and volume is milliliters in a lab using the metric system. And that 0.5 is uncertain. What if it was really 0.4 or 0.6? Well, it's uncertain, but I know for certain it's at least 21 milliliters. So that's involved in all measurements. Now, we also have what's called significant figures. When you take a measurement, significant figures, and I'll never ask on a test, what's a significant figure? Those are the digits in any measurement that are known with certainty plus one digit that's unknown or uncertain. And I'll explain more about this in a little while. Now, there's also another type of number called exact numbers. And those are numbers obtained by counting items or numbers that are part of a definition. If we're in a classroom right now, face to face, and I said, how many live people are in this room? And assuming everybody's alive, you're not going to say, well, there's 21.5 people. You can't have a half a person alive. You can't. So you'd say it's either 21 or 22. That's a exact number. If I asked how many cars are in the parking lot, you would count, well, there's 10 or 11 or 15. You couldn't have 12.5 cars or 12 and a half cars. You're not going to find a half a car in a parking lot. That works. Those are exact numbers. Now, when we have a number that's measured, it's important to be able to determine the number of significant figures in that number. Time for Dr. White to be subtle. Know how to do this. Now, I'm going to be going through some guidelines or rules how to determine how many significant figures are in a number. I will never ask you to write down the rules on a test, but I will expect you to know how to use these rules. Now, the first one is all non-zero numbers are significant. Therefore, if I were to ask you, oops, wrong color, how many significant figures are in 125, the measurement, how many significant figures? Well, the number 1, 2, and 5 are all non-zero. There are 3 of them. So this number has 3 significant figures. All non-zero numbers are significant. Now, listen carefully. You're going to be using this all semester on your test, because I'm going to be telling you later on, and we'll go through that today or tomorrow, we'll finish up. Any calculation you do on my test, it'll say, please use proper significant figures for all calculated answers. If you don't, I take off a point. And if there are 5 or 6 of those, you can lose some points on a test. Now, at first, this seems hard, but after a little practice, and I do have practice problems for that, there is a practice problem set for Appendix A2, A4, but at first you say, oh, this is hard. After a while, you say it's not that hard. All right, zeros may or may not be significant. Why, that wasn't helpful, but now let's talk about zeros. Lead zeros at the beginning of a number are never significant. Leading zeros are never significant. So let's take a look at this number. And the question is, how many significant figures are in that number? And on the whiteboard, not on a test, you'll see me using the abbreviation SF for significant figures. All right, lead zeros are never significant, so you ignore these. Non-zero numbers are significant. So 1, 2, 3, 4. So this number has 4 significant figures. Now, one of the things I haven't done is give you a chance to try some. So I will. How many significant figures? Remember SF, I'm abbreviating because I'm lazy. I don't want to write it all out. Are in, let's try this number. Question A, your turn. How many significant figures are in that number? And if you're done, remember, vote yes, please. All right. All non-zero numbers are significant. So there's 1, 2, 3, 4, 5. This has 5 significant figures. Now, when you have scientific notation, you ignore 10 to the x. Or 10 to the n. So how many significant figures would be in 3.567 times 10 to the 5th? Remember, vote yes when you're done. Everybody's done. So if we look at this number, all non-zero numbers are significant. We only look at this part. This part we ignore for significant figures. All non-zero numbers are significant. There's 1, 2, 3, 4. So this would have 4 significant figures. All right, let's move on. So Oh, I forgot to, I better do a lead 0 too. Let's do one more. How many significant figures are in that number? I see somebody's got it down. I think everybody does. All right, my turn. Lead zeros are never significant. Non-zero numbers are 1, 2. So this would have two significant figures. And now let's move on. And remember, I haven't said this in a while. In my class, in my world, there's no such thing as a dumb question. Always feel free to ask questions. And don't forget, today from 6 to 7 p.m., I have my office hour. Now, confined zeros, those between non-zero numbers, are significant. So confined zeros, and this would be an example. This would be a confined zero. This zero is in between two non-zero numbers, and that makes it significant. So all non-zero numbers are significant. All confined zeros are significant. So this would be 1, 2, 3, 3 significant figures. And why don't you do this one? How many significant figures are in that number? 83501. I see everybody's done. And I know one student's really getting it good. I hope everybody is. So if we look at this number, non-zero numbers are significant. There are 4 of them. Now, zeros may or may not. This is confined. It's between two non-zero numbers, which makes it significant. 1, 2, 3, 4, 5. And this would have 5 significant figures. Wrong button. Now, trailing zeros, those at the end of a number, are significant if a decimal point is present in the number. Again, trailing zeros, those at the end of a number, are significant if a decimal point is present in a number. Now, trailing zeros, those at the end of a number, are not significant if the number lacks an explicitly shown decimal point. So zeros at the end with a decimal point are significant. Zeros at the end without a decimal point are not significant. And let's look at examples of that. Now, if we look at this number, 93.00, all non-zero numbers are significant. We have a decimal point that is present, so that makes these zeros significant too. So all these are significant, and that would be 4 significant figures. Now, if we look at this number, there's no decimal. and trailing zeros at the end without a decimal are not significant. So all non-zero numbers are significant, 1, 2. These zeros are not because there's no decimal, so this would have two significant figures. Again, zeros that are confined are significant. Zeros that are leading are not significant. Zeros at the end of a number with a decimal point are significant. Zeros at the end without a decimal point are not. So let's try a couple more. Here's one for you to try. When I do this, that means starting a new section. I don't know where I picked that up in college when I was taking my notes. But anyways, how many significant figures would be 888.0? All right, let's take a look at this. Non-zero numbers are significant. Oh, we've got a decimal point. And therefore, zeros at the end, trailing zeros when there's a decimal, are significant. 1, 2, 3, 4. So this would have 4 significant figures. Oops, I don't know why that 0 didn't stay with the 4. Well, let's do another one. How many significant figures are in this number? All right. Well, all non-zero numbers are significant. There are 4 of them. But here we have zeros, but no decimal point. And that makes them not significant figures, or you don't count them. So this would have 1, 2, 3, 4, 4 significant figures. Ooh, let's try this one. This is a little more tricky. How many significant figures in that number? All right, let's take a look. Now, non-zero numbers are significant. Ooh, we've got a decimal point there. Lead zeros are not significant. Trailing zeros after a decimal point at the end of a number are. So this would be 1, 2, 3, 4. This would have 4 significant figures. Let me go through it again. Lead zeros are never significant. Non-zero numbers are significant. 0 at the end, where there's a decimal point, would be significant. So that's how you get 4. Try this one. All right. Now, once again, we do have a decimal point here. Lead zeros are never significant. Non-zero numbers are always significant. And zeros at the end with a decimal point are significant. So let's have 1, 2, 3, 4, 5 significant figures. And now let's try one more. Let's make it a little interesting. And here's one for you to do. All right, so let's look at this one. All non-zero numbers are significant. 1, 2, 3, 4, 5. We have a zero, and it's confined between two non-zero numbers. This zero will be significant. Now, we have zeros at the end, but no decimal point. And therefore, trailing zeros at the end without a decimal point are not significant. And this would be 1, 2, 3, 4, 5, 6. And that's how you do significant numbers. Now, I don't know if I'll get to it today, but tomorrow I'll tell a story how significant figures and my knowledge of them, and something I'll also be teaching you called rounding off, saved the company I was working for $400,000 with one phone call. And I'll probably get to that tomorrow. So you don't want to miss that story. It's a good story. I hope all my stories are good, but this one's a doozy. All right, let's continue on. Now, there's a practice problems for doing significant figures. I'd highly recommend you work on that after you do chapter 1 practice problems. Now, there's something you might be familiar with called rounding off. And that's the process of deleting unwanted, non-significant figures from a calculation. Because when you do a calculation and you have numbers that are different significant figures, how many significant figures should your answer have? Well, we have rules that I'll teach you today or tomorrow, and you use rounding off. Now, rounding off, I'll never ask you what are the rules, but I'll show you, and we'll only do this for scientific notation, because that's what you'll be doing in my class. The first digit to be deleted, if that's 4 or less, you simply drop that and all the following digits. And I'll go through examples of these. You know, by now I do that. I just don't leave you on your own in the dark. That wouldn't be nice. That's not how I operate. All right. Now, the other rule is if the first digit to be deleted is 5 or greater, that digit and all that follows are dropped. And the last retained digit is increased by 1. So what does this mean? Well, let's take a look at this. You remember when I was doing the calculator, I had some really big numbers like 1.7654327172, whatever. Well, how would you round this off to three significant figures. So what do? Well, we start at the beginning, the first non-zero number of a scientific notation. It's going to be this number to the left of the decimal point. That's my first significant figure. This is my second. This is my third. Now, how do I round that off to three significant figures? The first number I'm going to drop, and I have a habit of using a double squiggly line. I don't know, is that a word, squiggly? Well, I just made it up. If it isn't, well, I made it up a long time ago. You look at that. And the first thing you have to determine is that 4 or less or 5 or greater. And time's up. Hopefully you all picked it was 5 or greater. Therefore, I'm going to drop this number, this, and this number I will increase by 1. This part doesn't change. And notice the number I now have has three significant figures, 1, 2, 3. Again, you count the number of significant figures you want to keep, and the next one you use after that to round off. And you drop that. If it's 6, 5 or higher, you drop it, and the number in front of it, you increase by 1. Let's do another one. And the question is, how do you round off this number to two significant figures? Well, you keep the first two significant figures, the 6 and the 5, because remember, there's a decimal point there. Then we take the next number, which is what we're going to drop, the number right after the last digit you keep, and you look at that. That's where I use my double squiggly lines to get your attention. Is this number 1, 4 or less, or 5 or higher? And 5 or higher? Nope, it's 4 or less. So I'm going to drop that and everything afterward, and then this stays the same because it's 4 or less. This part you don't change. So that'd be 6.5 times 10 to the minus fifth. And notice for significant figures, you just use the front number, and that's 2. And here's one for you to try. Round that off to 3 significant figures. All right, my turn. How do we do that? We keep the 4 because there's a decimal point. Keep the 3, keep the 7. That's my 3 significant figures, 1, 2, 3. Use the 8 to round off. Is that 4 or less, or 5 or higher? And 5 or higher. So I'm going to drop that, everything else, and when it's 5 or higher, the number in front, the last one you keep, you increase by 1. So that would be 4.38 times 10 to the 16th. Now, let me show you an example that can get tricky. Now, let's look at this number, and let's say we want to round it off to 3 significant figures. And I'll do this one. So we keep the 4, because there's our decimal point, keep the 8, keep the 9. The next number we use to round off, and that is 7. Is that 4 or less, or 5 or 5 or higher? Well, and 7 is 5 or higher. So this number we drop, and we increase this by 1. Well, what do I do? Well, that would be 1.0 if when you increase that by 1 and you add it to the 0.8. So the number by increasing it by 1 becomes this number. Everybody with me? Give me a thumbs up if you're with me on that. Either use your emoji or your thumbs up on the screen. I see one question mark on somebody's mind. Oh, nope. Let's do one more. And why don't you round this off? You'll find, because I grew up with the slide rule, which you can only get 3 significant figures, I get into my 3 significant figure rut, which I am in right now. But why don't you round that off to 3 significant figures? This one's challenging. Let's see if you're up to it. All right, my turn. So there's a decimal point, and this is kind of rounding off. You're going to do mainly in my class. Keep the 5, keep the 9, keep the 9, and use this to round off. Is that 4 or less, or 5 or higher? And it's 5 or higher. So I'm going to drop all these, increase that by 1. Well, that would be 0.10. But when I add that to 0.9, that becomes 1. So the correct answer is 6.00 times 10 to the 6. And notice zeros after a decimal point that is explicit, which it is, are significant. 1, 2, 3 significant figures. And do I have time? I do. Now, many years ago, I worked for this one company, CHEMI, which was located in, I can't remember where it was located, not Forest Park, McCook, Illinois. It took me a second. It's been a long time since I had to think about it. And we had a plant down in Morris. And my job, I was in charge of a major research group, and our job was process and product development. And part of my job was, an important part, was to deal with our plants. Anything new I invented, I went down there and helped supervise the first, second, third time they ran it in a plant to make sure they did it right. And whenever there are any plant problems, I got a phone call from the plant manager. This isn't working right, help. And that was my job, to solve those plant problems. And I did those worldwide. I remember one time I was in Europe, in the Netherlands, and the VP of manufacturing in the Netherlands called me up and said, I know you're here on a trip, but I'm going to have someone, can you go to France? They're having a problem and you need to solve it. And I did go down to France and solve it. Well, anyways, I worked for this one company, and our supplier was another company called Unichem Chemicals. And Unichem had some problems supplying us with good quality material. And I went and talked to them and said, this is how you solve your problem. Because by solving their problem, I made my life a lot easier. Well, this impressed the president of Unichem a lot. Here's some outsider coming in and solving our problem that we couldn't. Well, it turned out their laboratory manager in charge of all quality control and research in North America was retiring. And the president of the company called me up and said, could you come and talk to me? I said, all right, sure. We'd like to offer you a job as laboratory man. I don't know if I'm interested. Then they made me an offer I couldn't refuse. They doubled my salary, doubled it. And you know what? I went. Well, now I'm at a company that's selling product to a company I worked for before that I knew everybody at the main plant this product goes to. Now, what you don't know is chemicals have what's known as specifications. You're familiar with specifications. If you go to a car dealership and you buy a car, you're going to say, I want a red or blue car. And that you're specifying what color. When you go to pick it up, you expect it to be that color. You wanted a red color, you don't want a yellow or green one, you wanted that red one. It's in specification. Well, there's certain measurements of chemicals that are in a contract that are called specifications. And if they don't meet that specification, the company that's receiving it can say, this isn't good, take it back. And we're talking about tank wagons and railroad cars. Tank wagons hold 40,000 pounds. Now, there's this one specification, which I won't really go into what it is, called iodine value. And in the contract, the iodine value was 94 minimum, two significant figures. However, when you measure iodine value, you can get three significant figures. Well, we shipped them a load, and my lab had 94.3. We were above 94 minimum, and it was valid product. Well, when a chemical company receives important products for their manufacture, they measure certain specifications too. And the quality control lab, we call QC lab, got 93.8. So let's take a look at this. My lab shipped at 94.3, and they got 93.8. And the spec was 94 minimum. So it was 94 and above, the company had to accept it. Well, the quality control manager at QC at the Morris plant, who I knew quite well because I'd worked with them for many years when I worked for that company, called me up and said, well, you know those 4 tank wagons, 160,000 pounds, $160,000, they're out of spec. I'm not going to take them, you take them back. And I said, wait a second. And part of my job at this point was in charge of quality control, along with managing research at the new company, which is why he called me up. And by the way, anytime a shipment leaves a chemical company, it goes with a certificate that's signed by the quality control manager of the shipping company, testing those are the actual measurements for key specifications, which I signed off on that. And I said, do you have a copy of the contract in your office? Which I knew he did, and I did. Took it out, and we saw it was 94 minimum. I said, Bill, that's two significant figures. If you round my number off, 94.3, I dropped the 0.3 because that's 4 or less. That's 94. I'm in spec. We look at your number, 93.8, round that off. 0.8 is 5 or higher. The 3 you increased by, that's 94. You have to take it. Oh, is he mad? I can't say the words in public what he said on the phone to me because he knew he had to take it. And then I apologized to him and I said, look, I apologize, this happened. We'll never ship anything to you less than 94.5, even though it's 94 minimum. And the next day I drove out to Morris and took him out to lunch. And we had a few drinks. I got him drunk. That happens in the chemical industry. And he was happy because he knew I wouldn't ship him that low. And I talked to our production manager. He got upset. Well, we can ship down to 94. I said, no, because it's not going out the plant unless I sign the certificate analysis. And I'm not signing it less than 94.5, because that will make our life a lot happier with this customer. And he got mad, went to our boss. My boss said, no, I'm right. So rounding off plays an important part in significant figures too. All right, so that's how you round off. Now, when it comes to math, there's certain rules that we use to determine how many significant figures are in an answer. I will never ask you the rules, but I will expect you to know how to use them. Aren't you glad I'm subtle and know these rules? The first one is multiplication division. When you do a multiplication or division, the number of significant figures in the answer is the same number of significant figures in the measurement, meaning the number you're multiplying and dividing, that has the fewest significant figures. Again, when you do a multiplication or division, the number of significant figures in the answer is the same as the number of significant figures in the measurement that contains the fewest significant figures. So what does that mean? Well, let's take a look at this. Oops. And the question is, what's the answer to this using proper significant figures? So I'm going to pick up my calculator, turn it on, clear it, 4.36 blue double E 4 times 3.111 blue double E 3, and my calculator gives me this number. If you write that down in a test, I'll take it off because that's not right using significant figures. How do we do this? First of all, how many significant figures in this number? And the answer is 3. All non-zero numbers are significant. How many significant figures in the second number? And that would be 4 significant figures. Now, which one of these two numbers is the lower one? Time's up, the answer is 3. So now we have to round this off. I forgot, I should abbreviate. The 3 significant figures. So how do we round this off? Keep the 1, keep the 3, keep the 5. Those are my 3 significant figures. Why? Because when you multiply and divide, the answer has the same number of significant figures as the number you're multiplying and dividing that has the fewest significant figures, which we determined was, in this case, 3. So I now use my 6 to round off. Is that 4 or less or 5 or higher? 5 or higher. So this number is 5 or higher. I drop this, increase this by 1, and the correct answer using significant figures is 1.36 times 10 to the 8th. When you multiply and divide, you get the same number of significant figures in your answer as the number that has the fewest significant figures that you're multiplying or dividing by. In this case, 3 is less than 4. And then you round off that number to those significant figures. Oh no, if I look at the clock, time flies when we're having fun with chemistry and Dr. White. Wow, it's another full day we got through. And you learned a whole lot of neat stuff. Now, tomorrow, I'll be doing the second lab. Don't forget, the lab we did yesterday, the safety lab where you have to fill in those answers, that is due tomorrow. You'll upload that as a single PDF file to Blackboard in the assignment area. If you have any problems with the first one, let me know and I'll help you out. Sometimes you do. If you have problems, don't forget you're always welcome to come to my office hours on Monday and Wednesday evening from 6 to 7 p.m. With that, I'll use the way since the pandemic started, I'll say "Gehen gesund." Remember, that's Yiddish for go in health, which is important during the pandemic. In fact, sometime later in the next couple of days, I'm going to be getting my 4th shot, second booster. I got 2 original. I think it's 4th or is it 5th? I lost count already. But anyways, Gehen gesund. Goodbye now. If you have any questions, I'll stick around, but Gehen gesund. Goodbye.